The first one here says a ball is projected horizontally from the top of a cliff with a velocity of 30 meters per second. If it reaches the ground 5 seconds later, calculate the height of the cliff. Now, I told you when we were doing the class in our previous lesson that when a question on projectile is given without angle of projection, treat it as if it's motion under gravity. In short, it's motion under gravity. In other words, you don't use all this formula that we derive here. Rather, you use normal equation of motion. So, which is a solving from principle. So, in this first question here, there's no angle of projection. We are going to use the first principle. The ball is projected horizontally from the top of a cliff with a velocity of 30 meters per second. I say projected horizontally. So it's as if this is a cliff, a platform, the ball is here, then somebody here kick it in a horizontal direction with a velocity of 30 meters per second. Then the ball will, of course, roll on the cliff. Then when it gets to the edge of the cliff, it will then fall down to the ground. Am I right? So this falling down to the ground is independent of the velocity of projection. When something is free to come to the ground, whether there is velocity of projection or not, naturally it's going to come to the ground. So when something is released from a height, initial velocity is zero. This thing falling to the ground does not depend on the velocity of projection. Rather, it depends on gravity only. So initial velocity is zero, not this 30 meters per second. We don't use that. So it reaches the ground 5 seconds later. G is 5. And then, of course, it's under the influence of gravity. So G is 10 meters per second square. We have to find the height of the cliff, which is distance that the ball has traveled from the top of the cliff to the ground. So using an appropriate equation that contains U, T, G, and S, that should be S equal to UT plus half GT squared. And U is zero, so this first term, we can ignore it and concentrate on the second term, which is half times 10 times 5 squared. 2 here 1, 2 here 5, and 5 squared is 25. 5 times 25, that should be 125. So the height of the cliff is 125 meters above the ground.